So I welcome you all in this live class session, and I am Aaryan Mehra. Many of you are seeing me for the first time. I can see that there are many new faces here, and I will not waste your time by introducing myself. We will do that some other day. But more or less, today we are going to begin because of a very special motive, and that motive is that JEST exam is delayed, right? So this class will be recorded and it will also be uploaded later on the YouTube. So you can even see it on a YouTube if somehow you miss any of the class. Now, very importantly, the JEST exam is delayed. CSIR NET exam is delayed. So that is a question which comes to the mind that every exam is getting delayed. So are they even interested in people coming to the research field? Do the government even care about it? So you don't have to think about all of these things. And what we have to do at this moment is to improve ourselves, to focus on the studies and improve our physics, so that whenever exam happens, we are prepared. And that is the purpose of this classes, to stop the wastage of the time in overthinking and put you in some direction. Okay. Now this series, before I jump into everything, this lecture series is not a complete lecture series. It's not like if you watch this and then you are completely ready for every exam. So that is not the case. Definitely in these classes, I will tell you that what else you need to do. But these classes are basically, it will, most of the times it will be basics, very basics. Means we will be covering even a very tough topics like partition functions, Ising model, every tough topic. But 90% of the time, I will keep these classes as a basic thing. Okay, so we will have fundamentals, we will be covering basic numericals, easy numericals. Yeah, someone is say something. Yeah, okay, please mute yourself if possible. If you have to say something, you can use chat box. Okay, so we will keep it fundamental, number one rule. But yes, there will be, let's say, one class in out of 3 classes, or you can say 20-30% of the time what will happen is I will be even explaining the tough problems which are even difficult than just exam, and that will be done to make sure that your mind is developed to solve such kind of problems as well. But most of the times we will be focusing on basics. Now, why we need basics? And in JEST exam and in CSIR NET exam, how can we, why the basics are required? So the idea is that if you open up your syllabus, and if you read any of the line, okay, and then let's say the topic is magnetism, and in the magnetism there are 7 topics, 7 subtopics. I will make sure that you can give a brief idea about all those 7 topics. You know what are the formulas, you know what are the basic concepts, you know what are the basic numericals, and now you can solve the extra numericals, difficult numericals, and so on. So that no student can say that I do not have enough or I do not understand the concepts. Every student is able to relate things. Every student must be able to solve things. That is the first priority here. Okay. And that is what we will be doing in these classes. Okay. So now JEST exam is 1 month. So I will not be teaching everything, but we will be very smart in our preparation. Yeah. Can you all listen to me, right? Yeah. You all can listen to me very well, right? Someone is saying I can hear. Am I audible, right? Sorry. Yeah. Thank you. Okay. Also, okay. Good. Okay. Perfect. Okay. Yeah. Thank you. Sure. Okay. So what we will do is we will be covering very smart studies. What are the topics we actually need to focus on based on the real life, means last 5-year trends. Okay, last 5-year trends, right? So let's see. So most of the students said that electromagnetism is a weak subject. So I'm starting with electromagnetism. So first of all, let's understand that what is the favorite thing about electromagnetism? What is just asking about electromagnetism? So let's begin with that. Okay. So in 2024, there were 5 questions. So every year in JEST exam from electromagnetism, you will have 9 to 11 marks. Okay. 9 to 11 marks will come from out of 100. So out of 100, 9 to 11 marks will go for electromagnetism. So basically it is not a very, very important subject, but it's not even, you can say that we can skip this subject and then still qualify the exam. Okay. And if you prepare very decent enough, you can easily 5 to 6 marks. 5 to 6 marks is very simple to score. You can very, very easily score this 5 to 6 marks. Okay. So that is the basic idea. How can we score this 5 to 6 marks in our exam? Okay. And what are the things we need to cover in a very short period of time? Right. So let's focus on that. So in 2024, they asked the question on magnetism, 3 marks on magnetism, 3 marks on magnetism. Then they ask electric field and Gauss law, multipole expansion, and Coulomb's law. So you see 6 marks are from the magnetism. I just want you to see the trend. Initially, 5 years ago, the trend was EM waves, electromagnetic wave, pucho, and put the questions in just of electromagnetic waves. But you see, from the last 5 years, you will see that electromagnetic waves are not even coming in an exam. Okay. Okay. 2023, you see then you see potential conductors. Now, this is a topic which no one covers. And it's not like a conductor ka properties. It's a numerical based on conductors. Then image problem. Now, image problem and conductor problem are very closely related. Very closely related. And then 3 marks again on magnetism. Now, magnetism is one of the subject which most of the students skip. But JEST is very much focused on magnetism. So 6 marks in 2024, 3 marks in 2023, and even 4 marks, I would say, because magnetic dipoles are also there. So 3 plus 1, 4. Okay. Again, in 2022, you see motion in electric field and magnetic field. That is also a part of magnetism, 3 marks. And then again, image problem is repeated. Potential conductor is repeated. Laplace and Poisson equation is repeated. So if you see that they are not asking the traditional topics, what they are asking is magnetism. So you can note down these things. What are they asking? Okay. So they are asking these few topics, only these few topics they are asking. So number 1, magnetism is most important. Then image problem and multipole expansion. Then electric field and Gauss law, Poisson's and Laplace equation, scalar and vector potential, conductors, and motion in electric field and magnetic. They are not asking boundary conditions. They are not asking EM waves much. They are not asking Faraday laws much, inductance, and these things are asked in electronics, but not as such a part of electromagnetism. Right. Now you might think that why electromagnetism is so less, means because there are only 6 subjects in JEST, and for 6 subjects you have 100 marks. So it means every subject should have more than 15 marks at least. And technically it should have 18 marks. Then why the electromagnetism only has 9 to 11 marks? Can anyone answer? Can anyone know? Does anyone know why electromagnetism has less marks? Means if you divide equally, you should have 18 marks. Then why electromagnetism only has 11 marks maximum? Yes, a very correct answer, optics. Because electromagnetism ka ek part which is written is also optics. Okay, so that is known as wave optics, interference, polarization, and diffraction. So rest of the 7 to 8 mark questions are coming from optics. So even though it's a separate subject, but in JEST syllabus, within electromagnetism, they have written optics. And also some part of electronic questions like capacitors, inductors. So that there's a merger of the topics. That is why you see the pure electromagnetism is less, and applied electromagnetism, where you see inductors or where you see interference and polarization, is more. Okay? We will cover that as well. Right. Okay. So one thing is very clear, we need to focus on these topics. So I will give you 1 minute to screenshot this, and then we will move to the first topic, which is magnetism. Okay. So we will begin with magnetism because it's the most important one. Any doubt till this point? Yeah. So magnetism ka first step. Lecture 1 is for first step. So if you are good in magnetism, today you are not going to learn something very new. So very basics I'm going to cover. How does the magnetism approach starts. Okay, so magnetism, in electromagnetism, you have to think in this sequence. Fields. Okay, so electric field, magnetic field, the entire electromagnetism runs behind fields. So what are these fields? So a particle experiences a force when it is in a front field. When do I say that in this room I have a field? So in this room, I will say there is a field if I am a particle and I am experiencing some force. Some force if I'm experiencing in this room, it means there is some sort of field which is there in this room. Now there can be different fields. There can be gravitational field. So if you are a mass, if you are a particle and you have a mass and you are experiencing some force because of your mass, it means there is a gravitational field in this room. Who is generating gravitational field? How the gravitational field came? Second question. That is a separate question. Okay. If you are a charged particle, either you are at a rest or you are moving. Both are possible. You might be at rest, you might be moving. And because of your charge property, you are experiencing a force. It means there is an electrostatic force in this room. Okay? And if you are a charged particle and you are at rest, you don't experience force. But when you start running, you start experiencing force. It means there is a magnetic field in the room. Because you were experiencing force only when you started moving. So you were a charged particle, but when you were at rest, you were not experiencing the force. But when you started running, you started experiencing the force. It means there was a magnetic field in this room. So field, whenever we come into play, always associate field with the force. So whenever you will open any electromagnetism book, they will do two things. Only two things. Number one, they will teach you how to find the field. So first part of the chapter will be how to find the field, gravitational field, electric field, magnetic field, whatever chapter you are studying. And the second part of the chapter will be, okay, now you know field, now find force. Okay. So we will also do like this. First, we will learn how to find the field, and then we will see how to find the force. Okay. So that is the point here. And we will focus on magnetic field. How to find magnetic field, and then if we know magnetic field, then what is force? Magnetic field is always comes into play when there are moving charges. Now, what is moving charges? There is another name of moving charges, which is known as current. So whenever the charge moves, we call it a current. So whenever you have to deal with currents or you have to deal with the charges which are in motion, magnetic field will come into play. Magnetic field always comes into play in two ways. Number one way, that there is already a magnetic field in this room. So in this room, there is already a magnetic field. Who generated it is a separate issue. Maybe there is a magnet, maybe because of the earth, maybe because of someone else. So there is a magnetic field in this room. And I am experiencing a force in this room. So I am a charged particle. I am running in this room and I am experiencing the force. That part of the story is known as force story. We will do it later on. That is a force story, right? The second part of the story is producing the magnetic field. So if I am a charged particle and if I'm running, I will also produce field. I will also produce field. Okay? So I am interested in that field. I'm not interested in the force acting on me. I am interested in the field which I am generating. That field I'm interested in. So if I'm a charged particle, I'm running, I am producing magnetic field. How to find that? Basic idea. How to find that? Okay? So there are two ways to find that magnetic field. How to find the magnetic field due to moving charge or currents? There are two ways to find. Number one is known as Biot-Savart's law, and number two is known as Ampere's circuit. Both are very important for the exam. Okay? So very quickly, I brought you to the story which I wanted. So how we come to this topic? Very quickly, I brought you to this topic. So one is Biot-Savart's law, one is Ampere's circuit. So Biot-Savart's law is a tough way of doing things. Ampere-Circuital law is a short trick of doing things because it is a very powerful law. Biot-Savart's law is an empirical law. Basically, it is backed by experiments. It does not come from the fundamental principles. It comes from an experiment, empirical law. Ampere-Circuital law, on the other hand, is a very theoretical, very conceptual law. Extremely conceptual law. It is one of the Maxwell equations. There are 4 equations of Maxwell which explains entire electromagnetism, and one of them is Ampere's law. So it means Ampere's law is very theoretical and very important law. So first we will understand Biot-Savart's law, then we will understand Ampere-Circuital. One very simple rule of the class is that we do not actually do the derivations. We actually discuss the results which are coming from the derivations, and because that is important for us, right? So first we will do Biot-Savart's. Okay. Do not try to make the notes along with the class. There is not need of that. So live class should be less stress on your brain. Okay. So when you're attending the live class, the biggest mistake that you can do is keep up the pace of making the notes. So if you're making the notes with me, that will be a problem for you. So I will share these notes with you later on. Then you can make the notes later on. At this moment, what you can do is mathematical formulas you can write. Any diagram if you want to make, you can write. And the numericals we will do, you can practice that. Okay. So keep yourself free in the live class. You can even watch the IPL match along with the class. There is no problem. You can scroll Instagram. Just listen to the thing, because this is not learning. This is just getting awareness. So live classes and classes are just for awareness. The real brain works when you solve the homework problems. So that is a time when I want you to use your brain. At this time, I just don't want you to use your brain. Just relax your body and enjoy the lecture. Okay. So don't try to make notes with me as such. Otherwise, you will feel pressure. Okay. So let's start with Biot-Savart's. Biot-Savart's law, as I said, is an empirical law, comes from the experiments, and it finds the magnetic field due to small currents. So Biot-Savart's law has a very simple story. So Biot-Savart law, okay, theek hai. Biot-Savart's law say you want to find magnetic field. Okay, I will tell you how to find magnetic field. You want to find magnetic field due to current. So let's say this is a current wire. You can see this is a current wire. So okay. So Biot-Savart's law, this is a current wire. I cannot tell you how to find in one step, but I will give you 2 steps. So Biot-Savart's law says that assume a small wire, small part of the wire. Don't take the entire wire, but just take the small part of it. And let's say this length is dl. Now it also has a direction, so we have to say dl vector. And the current in the wire is known as I. So if I multiply I with dl, this has a special name which is known as current element. Element of a current is current element. Okay. So Biot-Savart's law says I can tell you how to find magnetic field because of this small piece. Then Biot-Savart's law say, okay, I'm your brother. Tell me where you want to find magnetic field. So I say, okay, Biot-Savart's law, sir, please find magnetic field at this point P. Okay, Biot-Savart's law say, okay, your element is here. This is your element. Point P is here. Connect these 2 points with a vector, R vector. Can anyone tell me what do we call this R vector in physics? What is the name of this R? Sorry? There is a name for this. What is the name? Position vector is a wrong name. Position vector is with respect to origin. This is between 2 points. So what do we call this? Displacement vector. So the name of this is displacement. Whenever you are finding the difference of 2 points, basically connecting one point with the other point, that is known as displacement vector, not position vector. Position vector is with respect to origin. So we have not explained the origin here. Okay, we have not introduced the origin. So this is a displacement vector. So I give R vector. So let's say you are a boss, you are Biot-Savart's, and I come to you. I come to you with 3 informations. Number 1 information: what is the current in the wire? Okay. Then this dl vector. I give you current, I give you dl vector, and I give you the displacement vector. And then you give me the formula, and that formula is IDL vector cross r cap. R cap means direction. So if you just take the direction, then it is r cap, and if you take direction and magnitude, then it is a vector. So r vector is always equals to magnitude multiplied by direction. So vectors are always equals to magnitude multiplied by direction. So this is only direction divided by r square. Okay. Now, since you have only found because of the small element, and if you want to find for the complete wire, you know you have to do the integration. Very complicated formula. Luckily, in our syllabus or as such, you don't have to use this formula. Okay. The people have already used this formula and they have derived some very useful results. We need to focus on those results. Okay. So Biot-Savart's law gave a beautiful law, and now we will use it for a specific examples. And we will be discussing 4 examples. 4 examples. Biot-Savart's law are useful for only 4 things. Number 1, straight wire, not curly wire like this, straight wire, rings or arcs, solenoid, and toroid. So these are the 4 places where Biot-Savart's law works fantastic, and we can use it. And we don't have to derive actually what is a magnetic field and let's use Biot-Savart's law. We know the results. We need to keep those results in mind and analyze on those results. Okay. So 4 examples we will study, and number 1 begins with straight wire. And the question comes directly. So if you know straight wire, ring, solenoid, toroid, you will see the questions in an exam. Even in the part B syllabus of the CSIR NET, in the JEST exam, questions have came in the PYQ and they can again come. Okay. So let's begin. Okay. Always remember one thing, this is very important. Whenever you are studying a subject, for first 2 lectures, for first 2 days, do not think about PYQs. Because otherwise your entire thinking will be, you will be running towards PYQs and your concepts will have a gap. Because you are studying according to the PYQ. For first 2 days, complete the topic as such, whatever is needed to be done. And then you look at the PYQ and analyze what I have to do more. Which questions I have to do more. That is what PYQs are for. Many times what happens these days is from the very first day, the student is focusing on PYQ and not doing the topic as a complete. Okay? So let's see. Okay, straight wire. I have a straight wire. Beautiful. Everyone can see the straight wire. Okay. Before we jump into this, there was one interview question in IISc Tirupati. They asked me. So they first asked me the wire ki wajah se formula. They gave me some numerical and I solved it. And then in the end, one teacher asked me, where do you find electromagnetic field due to wires in the real life? Where do you need this? Why? Where we find magnet? Anyone? In physics, in engineering, anywhere. Why would you find magnetic field due to wire? Anything comes to mind?
In motors, sir.
Motors. Okay, that is motional EMF. Transformers is as such motional EMF or something. You are going in changing magnetic fields. Ammeter is a very good example. Ammeter is a very good example. Yeah. Now, what answer I want from you is a physicist answer. Don't give me engineering answer. Think about the what beauty of physics I can, what fundamental of physics I can explore from here. What physical laws I can find from here. What realities of the world I can know from this. If I know how to find magnetic fields.
Hall effect, sir.
Okay. Hall effect. Good. But that is force on charge, not as such finding magnetic. Okay. Let's think very fundamental. What is atom? What is atom? You have nucleus and you have electron moving. So this is who? This is moving charge. So even if you want to think about knowing atom, and if physicists would do what? Physicists understand, they give the theories. They do not use transformers. Physicists का काम नहीं है transformer use करना. ठीक है? That is something basically known as use of physics. So even if you want to think about, or if you want to know the atom, you need this, because as I said, we will be using it for 4 cases: straight wire, circular wire. So atom is a circular wire, kind of a circular wire. Moving charge in a circle is known as circular wire. Okay, so anything we know about atom starts from here. Okay, one of the basic fundamental. So you know Zeeman effect. So if you know magnetic field of an atom, and then you put that atom in a magnetic field, you see the Zeeman effect. So you cannot know the Zeeman effect if you don't know the magnetic field of an atom. One way of looking at it. Even your answers were all correct. Okay? But that is one way of looking at the things. So if someone asks you, keep these kind of things ready with you. Okay. Yeah. So let's begin. So now you all can see this wire. There is a current in this wire. Again, Biot-Savart will ask me the same question. Where you want to find magnetic field? I say I want to find magnetic field at this point P. Okay? At this point P. Then what is the perpendicular distance? मतलब कि इस पॉइंट P का वायर से what is the perpendicular distance? So I want a perpendicular distance. So that distance is D. So D is the perpendicular distance. Always remember, here I did not use D. So what I have done is, I have solved this entire integration. I have done all of that. For you, I have done that. For not me, but as a book author, someone has done it for you. And now I am going to give you the result. If you solve all of this integration, what do you get in the end? What is the last product you get? So in order to understand the last product, you need to know 3 things. Number 1, perpendicular distance and angles. So perpendicular distance is D. So you have to connect the wire perpendicularly to the point P, and that distance is D. Then you need angles. What angles? So what is the angle which this top part of the wire is making at P? So ये आपका wire था. This was your wire. This was your point P. This was a perpendicular distance. Now you have to see what is an angle this top part of the wire is making with the point. So let's call this angle as beta. Now you have to see what is an angle this bottom part is making with P. Let's call it as alpha. So now you know alpha, you know beta, and you also know perpendicular distance. Now you are ready for the formula for magnetic field, which is known as magnetic field is equals to nu naught I by 4 pi d sine alpha plus sine beta. Now, I promised you that we will analyze the formulas. We will not derive it. Okay? So let's start analyzing. Why there is a sign here? In this formula, why there is a sign? Sign क्यों है? We have not done the derivation, but why this sign came? Anyone? Sign function क्यों आया होगा इस formula? Guess. Although it's not a guess, it's a very clear. So basically, sign is coming because of this cross product. If you remember cross product, A cross B is given by AB sine theta. So sign must have came somewhere from there. Okay, why there are 2 sign here? Means one is alpha and one is beta. Why there are 2 sign? इस फॉर्मूला में 2 साइंस क्यों दिख रहे? Guess. Yes, what do you think? Why we have 2 sign in this form? बहुत easy है, ये सब सोचना बहुत easy है. Think about it. Not because of the wire वगैरह का नहीं पता ना. We have this formula. यहाँ से आया ना जो भी आया. Whatever came started from here. whenever you do integration, you put upper limit, you put lower limit. So you put the upper limit, you put the lower limit. So one upper limit when you put got sine beta, one lower limit when you put you got sine alpha. The last question, when you put upper limit by minus lower limit, there is a minus in between. But in my formula, there is a plus. Why? Why there is a plus and not minus here? Which minus into minus is plus? Direction of angle, yes. So some students, yes, some students are very much correct. You see, why we getting, you see, one angle is, here you see one angle is clockwise. On the other hand, another angle is anti-clockwise. So if you're seeing clockwise angle, always remember in physics, anti-clockwise angle is taken as positive. On the other hand, clockwise angle is taken as negative. Right? So I must have sine alpha minus sine of minus beta. Because beta is a clockwise angle. Beta is a clockwise angle. So now this negative comes out and this makes minus minus positive. Okay. So that is known as analysis of the formula. You should know in an exam, if you cannot forget this formula now. You cannot be confused कि यहाँ पे plus आना था कि minus आना. Sin alpha, sin क्यों आ रहा है? ठीक है? So these kind of confusions will not longer be there. Okay. So perfectly. Now sometimes what happen is that you have a wire, but now this time the point is outside the wire. Means this is a wire. Let's say this is a wire. What is outside the wire? So within in this range, this is inside the wire. But if you're here, somewhere here, then you're outside the region of wire. Okay. Then the formula changes very slightly. And why it is changing? You see, now you will be able to think much better. Why it is changing? Without derivations, you will be predicting the formulas. You see, if I now measure the angle, okay, so perpendicular distance is still d. Perpendicular, I'm finding the perpendicular distance. Perpendicular distance is still d. Now this angle is alpha. Now if you see, this angle is beta. Now you see both the angles are anti-clockwise. So this time with beta, I will not take a negative sign. So that is why this negative sign will remain there. So negative sign will preserve itself. Last time you see negative became positive because one angle was clockwise, one angle was anti-clockwise. But this time both the angles are anti-clockwise. So we are happy to announce that we will have a negative sign in middle. That is the only change that will happen in this formula. So if the point is outside the wire, the only change that will happen is that you have to put a negative sign instead of positive in between. Now many people get confused. Should we use sine beta minus sine alpha or sine alpha minus sine? I always recommend one thing, that use this formula just for magnitude. So use this formula only for magnitude. So do sine beta minus sine alpha or sine alpha minus sine beta, your choice. Find the magnitude. And in order to do positive and negative, basically positive negative means direction. In order to find direction, use right hand thumb rule. So whenever you are using these two formulas, just find magnitude. Number minus 10, 10, 3, minus 3. Don't worry about that minus sign. Only worry about the magnitude part. And then you can use right hand thumb rule for more. Okay? How do we use right hand thumb? Okay? So let's learn. Everyone at this moment we will learn, right? In order to use right hand thumb rule, we should be very clear about the directions. Okay? So if something is coming out of the plane, we will say it is dot. We will give the symbol dot. And if something is going inside the plane, we will give it a cross. Cross means something is going inside the plane. Dot means something is coming out of the plane. So this is out, this is in. Okay? Very nice. Now let's learn right hand thumb rule very quickly. Most of you might be already known about it. So let's say this is a wire and I want to know the magnetic field here is in or out, or what is it? So what I have to do is I have to use my right hand we have to use a right hand. Now take the thumb. Everyone do this activity. Take the thumb. Thumb should be in the direction of this vector. So you can see this vector. So let's bring this thumb in the direction of the vector. Now your hand is ready. Okay. Now bring these fingers and touch the point. Okay. So touch the point. When you are touching the point, you realize that your fingers are going in. It's going in. So I can even show you with the circle. Okay. So if you see the rotation of the circle, this circle is going inside. It means the magnetic field is cross. On the other hand, at this point, if I ask you what is the magnetic field at this point, you can see the fingers are coming out. When you complete a rotation and then you reach this point, the fingers are coming out. So magnetic field at this point is dot. Okay, what if I ask you what is the magnetic field here? So you see, if you're completing a circle and you are here, and then you will go towards the left. And if I ask you what is the magnetic field here, then you complete a circle, you come here, and then you're going towards the right. So here the magnetic field is left, here the magnetic field is right, here the magnetic field is in, here the magnetic field is out. So that is how you use a right hand thumb rule. If anyone has passed the 12th examination, they must have done this in their tuition classes or schools. Okay, so that was a very basic revision. Now another very important concept here is sometimes we say the wires are infinite. Now wires are technically never infinite, but let's say if the wire is much bigger than the distance, means this wire is, let's say, 1 meter and this distance is 1 millimeter, then approximately this wire is infinite. So infinite wire means that wire is very long compared to the distance. So then we say that wire is infinite. If any side of the wire goes to infinity, then the angle from that side becomes 90 degrees. So if any sides go to infinity, then angle become 90 degrees. How? That is also important. These kind of things can be asked to prove you. Okay, anyone can ask you to prove these things. So let's understand why I'm saying. So let's say this is a wire, this is a point, and this is your angle alpha. Now I say that this side of the wire goes infinity. Means I want to make this infinity. Okay, so if this is infinity, it means very, very far away, somewhere very, very far away. And now this is alpha. Okay, now if you go even more far, this alpha get even bigger. Okay, if you go even more far, this alpha got even bigger. So you see, as you are going more and more and more far, this angle keeps on approaching 90 degrees. The moment you go to infinity, this angle will become 90. And there is a mathematical way of proving this as well. So how do you prove it mathematically? Very simple. Just take this as alpha. Let's say this distance is r, this distance is d. Now what you have to do, you have to do tan alpha. What is tan alpha? Tan alpha is perpendicular upon base. Okay, and this r, this is infinity, because I am saying that this is infinity. So tan alpha is infinity. When does tan become infinity? Tan becomes infinity when alpha will be 90, because tan is infinity when the angle is 90. Okay, so there is a mathematical way of proving this. Also, there is a visual way of looking at it. Okay, so any doubt at this point? And till this point, any doubt? Is it clear to everyone? I mean, you had a weak magnetism. Is it clear, everyone? Whoever had a weak magnetism? Okay. Any doubt? Please feel free. Because think of it like you are in class 11th and I'm your 11th teacher. Don't think of yourself as graduation. Okay. Hoping that it r is just anything I define. Nothing. You can call it as x. This distance. कुछ भी. ठीक है. Triangle बनाया ना. तो कुछ भी. Okay. Okay. Nice. Very nice. So one thing we learned is if any side goes to infinity, angle will become. Okay. Angle will become 90 degrees. Okay. So now if both the sides become infinity, Means if it's an infinite wire and both the sides become infinite, then both the angles will be 90. So if you have sine 90, sine 90, sine 90 is 1, sine 90 is 1. So 1 plus 1 is 2. So nu naught I by 4 pi d multiply by 2 will be nu naught I by 2 pi d. Nu naught I by 2 pi d. That is a very simple thing. Okay. Sometimes we also follow semi-infinite. Semi-infinite. Semi-infinite means, okay, this side is not in infinity, but one side of it is going to infinity. So if this side is going to infinity, then this angle becomes 90 degree. But this point is at 0 degree because you can see there is no angle. Because if you see, this angle will become 0 degree. If you bring this point here, then the angle will become 0 degree. Okay. So one side is becoming 0 degree, one side is becoming 90 degree. Okay. So if you just put 1 0, so if you put 1 0, this is 0. But if you put sine 90, that is 1. So then you get nu naught I by 4 pi d. So nu naught I by 4 pi d is your answer in this case. There are multiple cases. I mean, this is just 4 cases I'm explaining, but from these 4 cases, you can make anything. Okay. For example, I can say, what if there is a semi-infinite wire and the point is here, and I give you this distance. Now you can easily calculate the angles and then you can solve the question. Okay. So we will be doing such practice very soon. Next thing we will do is practice. Okay. So number one thing we learned is Biot-Savart's law. Then the author of the book solved the Biot-Savart's law for straight wire. Then we understood the formula, why this formula should come without doing the derivation. Then we see that what will be the change if the point goes outside. Then we see what will happen if the wire become infinite. Okay. Someone is asking how to do the right hand thumb rule. Don't worry, when we will be solving the questions, we will be doing it again. You will understand that. Okay. So now we will have some very basic question practice. Very basic. I mean, this question I'm taking from JEE. But you see, if you go and search CSIR NET Part B or you search JEST PYQ or JAM PYQ, you will find the similar question. Okay. So it's not like it is not important for us. But this is a very fundamental question. Okay. So let's solve this. So you have two long straight wires. There are two long straight wires. We see that. Equal current in opposite direction as shown in the figure. If the length or the dimension of the wire is not mentioned, assume it as infinite. Okay. If it is not mentioned, assume it as infinite. Because even if it is said long, long means infinite. If the length and other things are not given, assume infinite. The separation between the wires is 5 centimeters. Okay. What is the magnetic field at the middle? Okay. So this is a fundamental question. Next question will be difficult. So take very good care here, and next question will be difficult. So two wires, and we want to find magnetic field in the middle. Always remember, in magnetism, the only mistake that can happen is in the direction. If you get the direction wrong, your question will be wrong and they will make you do the mistake in the direction. Okay? So let's understand the directions very carefully. So let's first think about this wire. This is an infinite wire. Magnetic field due to infinite wire is given by nu naught I by 4 pi d. So Anuj already made the mistake. That is the mistake I was talking about. So nu naught I by 4 pi d, sorry, 2 pi d. I'm very sorry, 2 pi d. You can see magnetic field due to infinite wire is nu naught I by 2 pi d. Okay. Now let's think about the direction. Take the right hand, put the thumb in the direction of the arrow. So ye arrow hai, this is arrow. Now I want magnetic field at this point. Chaliye. So if I rotate my fingers are going inside. In. It means the magnetic field is in. And whenever there is a in, we use cross. Okay. So magnitude, I know. How much is the magnitude? Magnitude is nu naught I by 2 pi d. So this is nu naught I by 2 pi d, nu naught I by 2 pi d. Magnitude is nu naught I by 2 pi d. And what is the direction? Direction is going in. That was simple. Now think about here. Okay. Now, again, my thumb should be in the direction of vector. So I have to first position myself in such a way that my thumb is in the direction of arrow. Okay. And now I want magnetic field here. Thumb here. Now, if you rotate again, you will again see that your fingers are going in. You can check that. Going in. Right? Everyone can see going in, right? Everyone clear ki why? Because of this wire. Magnetic field here is going in. किसी को doubt है तो just write down. No other problem. Why magnetic field? Because of this wire is going in. Anyone have a doubt? Write down. Yeah, clear. Done. Everyone understand? समझ आ रहा है? Can we move forward? In. I can see in from both sides. Yeah, your response will be well valued here, sir. Yeah, please go ahead. Any doubt? Here we have to spend some time. Why? Because the directions are the one place where you can make mistake. एक बार हिंदी में भी करते हैं. If anyone understands in Hindi better. तो अपना थंब वेक्टर की डायरेक्शन में लेकर गए और अब आप सोचो कि पॉइंट कहां पर है. पॉइंट जहां पर है, रोटेट द फिंगर्स एंड देखो कि वो जहां पर पॉइंट है वहां पर आपकी फिंगर्स अंदर जा रही हैं या बाहर. ठीक, तो ऐसा ऊपर किया, अंदर जा रही है. ऑन द अदर साइड यू सी द वेक्टर रोटेट, वेक्टर की डायरेक्शन चेंज कर दी, करंट उल्टी डायरेक्शन है. तो फिर मुझे अपना थंब वेक्टर की डायरेक्शन में लेके जाना है. अब जो मेरा पॉइंट है वो इधर वाली साइड, अगेन आई एम रोटेटिंग माय फिंगर्स, इट इज अगेन गोइंग इन. तो दोनों की वजह से अंदर जा रहा है. हाँ, इफ समथिंग लाइक दिस वुड हैव बीन देयर, समथिंग लाइक दिस वुड हैव बीन देयर, तो देन इसकी वजह से इन एंड इसकी वजह से आउट. बिकॉज यू सी इन. बट नाउ लेट्स थिंक अबाउट द अदर वायर. अदर वायर की वजह से अगर मैं देखूं तो जब मैं घूमा, अगर मैं यहाँ पे फिंगर, यहाँ पे मैं अगर अपना थंब रख के घुमाता हूं तो इन हुआ ये और आउट हुआ ये. बिकॉज यू सी यहां से मेरी फिंगर्स इन होंगी और घूम के फिर दूसरी साइड से आउट. सो वन इन अनदर आउट, देन इट विल बी जीरो. बट इन दिस केस दे हैव डन अ वेरी गुड थिंग कि करंट की डायरेक्शन ऑपोजिट कर दी. दैट इज वाई दोनों की वजह से ये क्या हो गया, इन. ठीक. यस. इज इट क्लियर टू यू ऑल? यहाँ डायरेक्शन समझ गए? देन इट इज इजी. हाउ डू द डायरेक्शंस आर सेम गिवन द करंट्स आर इन ऑपोजिट? तो करंट ऑपोजिट में तो क्या फर्क पड़ता है, लोकेशन ऑफ द वायर भी तो अलग है. सो समवन इज सेइंग दैट wires have the current in opposite direction, then still the magnetic field is in the same direction. Q. You see the location of the wires are also different, na? So for first wire, the point is on the right hand side. But for the second wire, the point is on the left hand side. So ये भी तो अलग है ना फिर. This is also different, right? That is the case. Okay, now let's go on. बढ़ते हैं आगे. तो फिर न्यू नॉट आई बाय 2 पाई डी इन एंड न्यू नॉट आई बाय 2 पाई डी इन, both are in, it means both vectors are in the same direction. It means we have to add them. If we add them, we say nu naught I by pi d. Okay, so 2 will get cancelled and now you can just simply put the values everyone can put. So I'm not going to put the values, you can put the values. Okay, so that everyone can do perfectly. So that is a good thing. Now let's move to the tough problem. So this is a tough problem and this will take some time. Okay, and that will be the last problem for today, and then I will give you some hope. There is a regular polygon of 6 sides. Hexagon is there. Polygon of 6 sides is a hexagon. By bending a wire, so you make a hexagon by bending a wire. So I give you wire and you bend it and you make a hexagon. The length of the wire was 4 pi. So length of the wire was 4 pi. Okay, and the current is flowing. This is the current which is flowing in the polygon. So this is a current which is flowing in the polygon. They are asking what is the magnetic field at the center. Find the magnetic field at the center. So if you find the magnetic field in the center, so there is a very simple trick. Polygon or any triangle, square, 6-side, 8-side, 10-side, does not matter. You find the magnetic field due to one wire and then multiply by whatever number you have. So you just find the magnetic field due to this wire. Then magnetic field due to this wire will also be same, due to this wire will also be same, due to this wire will also be same, due to this wire will also be same. So for if you find magnetic field due to one wire, then for all other wires also the magnetic field will be same. So what you do is you multiply by 6. Okay. So magnetic field total is equal to 6 times magnetic field due to one wire. Perfect. So all I have to do is find the magnetic field due to one wire. Now, very simple. What is the length of this wire? First of all, I need the length of this. Why? Length of this wire. Why I need the length? Because I need the length to find this perpendicular distance. Because in the formula, I know the formula is mu naught I by 4 pi d sine alpha plus sine beta. D is the perpendicular distance. So for this perpendicular distance, I need this length of the wire. Length of the wire कैसे निकालेंगे? Yeah, now someone asked that the direction of every wire is different. So why we are multiplying by 6? Okay, very simple. Let's. ये बहुत ही अच्छा सवाल पूछा. Actually, I skipped it, but let's do it. Okay, now let's get ready to make use of the right hand thumb. सबसे पहले let's find the magnetic field का direction due to bottom one. अब bottom one है तो अपना thumb लेकर जाओ जरा. Thumb लेकर जाओ. Imagine the thumb. घुमाओ. If you have the thumb, ठीक है, घुमाओ, तो your hands will come out. So यहाँ पर आपका magnetic field will be out. हाँ, अगर करंट उल्टा होता, let's say यहाँ पे करंट ऐसा है, तो at this point the magnetic field is out. क्योंकि अगर आप फिंगर्स ऐसे रखेंगे तो यहाँ से आप इन करेंगे और यहाँ से आप आउट करेंगे. Because you will enter from here, come out from other side. Similarly, अगर इस वायर में भी देखेंगे आप, अगर मैं इस वायर की बात करूं तो you will enter from here, come out from here. अगर मैं इस बात वायर की बात करूं, अगर मैं अपना if I put my thumb here, you will enter here and you will come out here. So what you see is कि for every wire your thumbs are coming out. So that is why the magnetic field due to all 6 are coming out. That is why I added all of them. That is why I said 6 times. Okay, that is why the direction यहाँ पर perfect है. ठीक है, चलिए. You can think more about it. So in, out. इसकी वजह से यहाँ पे in, यहाँ पे out. इसकी वजह से यहाँ पे in, यहाँ पे out. Right? तो यही हो रहा है ना, सभी 6 की वजह से यही हो रहा है. It will happen like this. Perfectly fine. Perfectly fine. Okay, now let's move on. चलिए, so what is this length of the wire? ठीक है, total length कितना था? What was the total length? The total length was 4 pi. Total length was 4 pi. Now this is, now what is the total circumference now? The total circumference is 6L. Means let's say the length of this thing is L, then the total circumference is 6L. So 6L is equals to 4 pi. So L is equals to 2 pi by 3. That is what you can see here. L is equals to 2 pi by 3. Perfect. Simple, very, very simple, very simple, very simple, right? 2 pi by 3. Now, simple trigonometry. 1 triangle, 2 triangle, 3 triangle, 4 triangle, 5 triangle, 6 triangle. So total 360 degree is divided into 6 triangles. It means 360 degree is divided into 6. It means 1 triangle is 60 degree. 1 triangle is 60 degree. So this pura triangle is 60 degree. But if I divide, this will be 30 and this will also be 30. Right? So it means alpha is also 30, beta is also 30. So I got alpha, beta, and alpha and beta are coming out. Now only thing that I need is this perpendicular distance. ये perpendicular distance चाहिए. I need this perpendicular distance. So how can I find this perpendicular distance? Trigonometry. Trigonometry. So use this OAB. OAB ये आपका 30 डिग्री है. Tan 30 डिग्री, tan 30 perpendicular. Perpendicular means सामने वाला. In front of you. So सामने वाला पूरी लेंथ तो नहीं है. In front of you is not complete length L. It is half of it, L by 2. And base. So base is your perpendicular distance D. Okay. That's all, right? Now you put the value of tan 30 and you put the value of L. You get your value of perpendicular distance, which is pi by 3. Now any smart student can put the values of D, alpha and beta in your formula and get the answer. Perfectly fine. This question, any part of the 3 part of this question are there. Number 1, realizing the fact that I just need to find magnetic field due to one piece and then I multiply by 6. That was the first concept. Second concept was to find angles, alpha and beta. Third concept was to find the perpendicular distance. 3 things you find and then you put it in the formula and you get the answer. Perfect. सबको समझ आया? Values you can put. वो आपका काम. Right. Done है जी, done. चलिए. 4 questions I'm giving you as a homework. Question 1, question 2, question 3, question 4. Now question 4 is for triangle. So now you multiply by 3 and angles will also change. Perpendicular distance will also change. Okay. And in question 3, how did L got cancelled? Which L got cancelled, my friend? No L got cancelled. L cancel नहीं हुआ. I put the value of L. I put the value of L here. I did not cancel anything. Okay. So I just put the value of L. Right? Okay. Yeah. Yeah. This video will be posted on YouTube after 20, tomorrow. Not today, tomorrow. Tan कर रहा है ना, because in the triangle angle is 30. I'm not using 30 from my side. Whatever is this angle, I can use only that. Na? So, right. What is 12? No, this is not a final answer. This is just B1. This is just B1. You have to multiply by 6 also. The final answer is 72. Final answer to this question is 72. Okay. So these are the 4 questions. In these 4 questions, one thing I need to explain in question number 3. So last thing for today. How 4 pi equals to 6L? Okay, understood. So the total length of the wire was 4 pi. आपको मैंने पहले एक wire दी and I said, okay, now make the hexagon from this wire. So the total length was 4 pi. Right? 4 pi. And now total circumference. अगर एक side L है तो 6 sides क्या होंगे? 6L. So 6L is equals to the total length of the wire, 4 pi. Now Ramesh is asking, what if one side of the wire is open? So then current will not flow. Then तो question ही खत्म. Current ही flow नहीं होगा ना. Right? हाँ कर लो. जो भी है वो तो there will be many such questions, right? You are asking for questions like these, na? Like these, na? Open wale. So that also comes. So whenever the wires are open, you also have a circular part. So when I teach you about the circular part, then these kind of questions will come. Okay? So we will discuss that also. Okay. That will be tomorrow's job. But yeah, let's see for the third question. So third question, I just want to tell you one thing. One concept that I want to let you know. If you have this wire, and if I ask you what is a magnetic field at this point, then the magnetic field at this point is 0. So basically magnetic field on the line of wire, is 0. If you put point on the line of the wire, then at that point magnetic field will be zero. So let's say this is the wire. Magnetic field at this point or this point will be zero. Okay. So that concept you can keep in mind for your question number 3. So these 4 questions you should be able to do it. So tomorrow's class will be a little bit fast. So today we covered very less because in the beginning I have to give you some introduction. Okay. So tomorrow we will complete other 3 things: circular, solenoid, toroid. Right. So by doing this, a good portion of magnetism will be done. So magnetism, we will cover it in some portions. So magnetism is divided. So you should know what we are going to cover. So first we did wire. So tomorrow we will be doing circle, solenoid, toroid. Okay. Then we will go for Ampere's law. Okay. And then we will go for magnetic movement. So this topic is also very important for all exams. These days, this topic is very important. So how do you find magnetic movement? Right. And that will be important. So tomorrow's class will also be at 10 to 11. And the recording of this class, I will let you know where I will upload. Either I will upload on YouTube or either I will put you in the app. Yeah, any doubt? It in the recording itself. Listening to the class does not make someone good physics student. What can make you a good physics student? This is class 11, purely class 11. Okay? So what you should actually do is you should search JEE PYQs, JEE mains PYQs. Try to solve those PYQs as much as you can. So daily 20 questions, 10, 20, 30 questions. Okay? So that will be very much useful, because ultimately you will see that those things are very much helping you and increasing the level. Rather than directly jumping to the PYQs of JEST or GATE or NET, start from JEE PYQs, because the direct questions are coming. That is why I'm asking you for this topic. Not for every topic. You can even try JEE Advanced. JEE Advanced problems are even more difficult than JEST. Many problems are more difficult than JEST. So even if you are not able to find the answer, your brain will start to work. Okay? So that is the most important part. Until unless your brain is not working, classes cannot help you. Classes just give you direction. Right? It does not make you a warrior. Problems makes you a warrior. So that is my suggestion. Class timings will be 2 times. Either it will be from 7 to 8 or 10 to 11. I will let you know every day if the class is from 7 to 8 or 10 to 11. Most of the days it will be 10 to 11.